Hello, my name is Maria from mathmammoth.com. In this lesson we're gonna talk about prisms and cylinders and find their volumes. First of all, what is a prism? What is its definition? In a prism we always have a polygon as a base and an identical polygon as the other base. And then those two are connected by faces, which are either rectangles then or parallelograms. Here's some examples. This first one here, it's called a triangular prism. Each prism is named by the shape that's the bottom face, or the bases. See, the bases are identical. Here's a triangle, here's a triangle. So it's a triangular prism. And this one is kind of slanted looking, so we call it oblique. It's not a right prism. Whereas this one here is intended to be a right prism. That means that if it was standing up, these faces here would be perpendicular to the base. The base in this case is here, it's a hexagon. The other base is over there at the back. And then this one here, what would we call that? Find the two polygons that are identical, that are the bases. Over here and here. This prism also is not standing up, so to speak. So this shape here is a trapezoid, so it's a trapezoidal prism. This one here, we call it a box, but in math we would call it a right rectangular prism, because the bases are rectangles, and also it's right, it's not slanted or oblique, it's right in the fact that these faces here are perpendicular to the base, and to the other base too. In a prism, these other faces that are not the bases turn out to be always rectangles or parallelograms, and if it is a right prism, they are rectangles. What is a cylinder then? In a cylinder, we have a circle or an ellipse or some other rounded shape as a base, and then another identical base once again, and then those are connected by one other face which wraps around the whole cylinder. So here we have a circular cylinder, and this is also not slanted, it's a right circular cylinder. We also have marked the height of this cylinder. This height is needed when calculating the volume. And the height is the length of the line segment that is perpendicular to both bases here. And while I didn't mention it, all of those prisms also have a height. It's the same concept as here with the cylinder. Now, the volume of prisms and cylinders is calculated the same way. It's the same formula. The volume is the area of the base times the height. Very easy. I need you to memorize it, okay? Area of the base times the height. Okay, so here's a right circular cylinder. Your task is to calculate its volume. Get out the calculator, pause the video for that. Now let's do it together. What was the formula again? Something times something. Area of the base times height. Here we have a circle as the base, so we need to calculate its area. How do you find the area of a circle? This here is the diameter, but the area of a circle was pi r squared. This r is the radius, not this. This is the diameter. So we actually need half of that, the radius. The radius would be 1.625 inches. And now the volume. It was the area of the base times height. So it becomes area of a circle first of all, pi times r squared, this one here, 1.625 inches squared. Okay, I put this entire radius with its unit in parentheses to square it. Then times the height, which in this case, you have to imagine, I mean, it's laying down, but if the cylinder was standing up, then this one here would be the height, but it's in feet and inches. Here we're gonna have inches and square inches. We need this in inches. So we have 2 times 12 is 24, plus 3, 27 inches. And we get approximately 223.99. And what's the unit? Here you have inches that become squared, and then times inches, so that's cubic inches. But we do want to actually round this some more. You've studied the significant digits by now, so let's look at those. This here has 3 significant digits. This one, well, once I converted it to inches, it was 2. So really, I need to round this to 2 significant digits. So just the 220 is what we leave for our final answer. 220 cubic inches. Another task here, another exercise, calculate the volume of this shape. What shape is it, by the way? You can guess it's a prism, right? It's a triangular prism. And the volume was, once again, area of the base times height. So where's the base? In this figure, the base is, remember, there's going to be two bases and they are identical. Here, and then over here is the other triangle, that is the other base. These other faces are rectangles. So we need the area of the base. How do you calculate that? How do you find that? This here is actually perpendicular to this line here. It's the height of this triangle. And now you need to know the area of a triangle. How was that? Base times height divided by 2. So we get the area of the triangle first, and then we multiply that by the height, which is what? Is it this or this? Imagine standing this triangle or prism up, standing it up instead of it laying down. This one is the height. This number we don't need for anything. Okay, so the volume, area of the base times height, and we have area of a triangle here, which is its own base. This is the base of the triangle now, times its height, divided by 2. I'll just put here times 1/2. And then, so this is the area of the triangle, and then that whole thing is times the height of the prism, 5.3 centimeters. There's our calculation. And we get 119.886. But what unit is it, and how do we round it? Centimeter times centimeter times centimeter. Okay, that's centimeter multiplied by itself 3 times, so it's cubic centimeters. And that makes sense because we are talking about volume. We get the cubic unit in our answer. Then rounding. Again, significant digits. There's 2 significant digits in here and here. So this one also gets rounded to 2 significant digits. 120 cubic centimeters. All right, we're all done, and I hope this was helpful.